Hello students, welcome to All Force e-learning. Yeah, let us go for a passage which is relevant to prism, refraction through prism. Now in this passage, so the data is given. So there is a prism which is right angled prism and its angle of prism is given 30 degree here on one side. We expect that here the angle is 60 degree. Okay. Now a ray of light is incidenting on the side AB, normal to it, and which undergoes TIR at the surface AC. And second ray is incidenting on it as shown in the diagram. So after refraction, it emerges perpendicular to the side AC. And third ray, which is incidenting as shown in the diagram on BC, then after refraction, it emerges such that the angle of emergence is equal to angle of incidence for the ray 3. So this is a clear data given. Once again, I repeat, there is a right angled triangular prism on which ray 1 is incident normal to AB. After refraction grazing the surface AC, and second ray incidenting on same side AB. After refraction, it emerges perpendicular to AC, and third ray is incident on BC, and after refraction it emerges such that the angle of emergence will be equal to angle of incidence for ray 3. Then the questions. Question number 1, that is 16th one, because so we finished up to 15th question and previous video. Now we started with 16. Even if it is passage, there are 3 questions in it, but this is the 16th one. So what is the value of refractive index of the prism? This is question number 1. And the question number 2 is, that is, deviation suffered by the ray 2 is. And question 3rd, that is 18th one, the deviation suffered by ray 3 is. There are 3 questions. Yeah, let us find first one. So what is the value of refractive index of this material medium? So very simple. As the data or explanation or the point was given in the problem, then according to which we followed as it is. Here the ray 1, that incident normal to AB, and after refraction grazing the surface AC. This is given, mentioned. Whenever it is grazing, definitely this outer angle will be, angle of emergence is 90 degree. This is critical angle on other side. Therefore, we have the concept that this is the 30 degree. So this is a 90 degree normal incidence. This is 60, and definitely critical angle is how much? This is 60. This is normal. Definitely critical angle is 30 degree. Therefore, using the formula Snell's law and also critical condition, critical case, critical angle, mu is equal to 1 by sin C. Yes, mu is equal to 1 by sin C is 30 degree, and simplifying mu is equal to 2. So this is the answer for the first question. It is over. Refractive index of material of the prism. Next, go for second one. Second ray is incidenting. After refraction, it emerges perpendicular to AC. Yes. So its relevant diagram is. Let us make this relevant diagram. See, this is a prism. Okay. Now this is AB. This is C. Now ray of light is incidenting on it, undergoes refraction, and this is emerge perpendicular to AC. This is emergent ray perpendicular to AC. Of course, a normal is drawn over here. This is angle of incidence I1, and here angle of refraction R1, and here I2 and R2, these two are 0. Why? Because for AC this is normal. If it is normal, the ray is traveling along the normal, the angle of refraction and angle of emergence, that is I2 and R2, become 0. Okay. Now using the condition here, R1, see here, R2 and I2 is 0. Okay, because it is emerging normal to AC. Therefore R1 plus R2 is equal to A. So here it is 30 degree. Now here it is A, angle of prism, which is 30 degree. Therefore using here R1 plus 0 is equal to 30 degree. R1 is equal to 30 degree. So R1 is calculated. By using R1, we can also estimate I1. I1 can be estimated by using Snell's law. Yes, by using Snell's law, already we calculated over here clearly. So no need to take here. So this is R1 plus R2 equal to A, R1 plus 0 equal to 30, R1 is 30 degree. So again using Snell's law, so here outside refract index is 1, and sin I is equal to mu into sin R1. So sin I1 is equal to 2 sin R1 is 30 degree substituted. Then by simplifying you will get 90 degree. Which one? I1 is 90 degree. I1 is 90 degree. Yes, I1 is at the surface AB. I1 is 90 degree. R1 is 30 degree. And it is traveling from rarer into denser, bends towards normal. Therefore, here in this case, I1 is greater than R1. Deviation suffered in this case I1 minus R1 according to the refraction conditions. When the ray is refracted through a plane surface, then the deviation suffered, either it is I1 minus R1 or I minus R or R minus I, depending upon the bending. Here in this case, rarer into denser, bending towards normal. Therefore, I is greater, I minus R is taken into account to find the deviation. 90 minus 30, which is giving 60 degree deviation suffered by the second ray of light. So here second ray, the ray 2 is suffering how much deviation? 60 degree. So answer is over for the second question, and third remains. In the third question, so question is given that ray 3 is incident on it. After refraction, it emerge. The angle of emergence, see here, the angle of emergence we can say here, this is say I1 or any I dash. So this is I1 dash, this is I2 dash. So here I1 dash, I2 dash both are equal. That is possible whenever the prism is in minimum deviation position. For this ray, here this is taken as angle of prism. This angle is taken as angle of prism. If you rotate this in this way, this is the prism, angle of prism, and it is refracted, it is in minimum deviation position. By giving its condition that angle of incidence and angle of emergence both are equal, it is possible whenever the light is symmetry inside the prism, about the prism, the refracted ray inside the prism will be symmetry, that the prism is said to be in minimum deviation position. Therefore, here I1 say I2, I1 is equal to I2, the prism is in minimum deviation position. Therefore, directly we can use mu is equal to sin A dash plus delta minimum by 2 by sin A dash by 2. Then here mu already calculated in the first question 2 is substituted sin 60, this is angle of prism here. Don't think of this angle of prism is again used over here. So this is different for these two rays, that is different. For this particular ray, this is the angle of prism. These two are different. Therefore 60 plus delta minimum by 2 by sin 30. By simplifying this, taking this side 2 into 1 by 2, 1, it becomes sin 60 plus delta minimum by 2 is equal to 1, then this will become, that is 60 plus delta minimum by 2 is equal to 90, taking this side 180 and simplifying. So deviation suffered, which one? Minimum deviation. So this is suffered minimum deviation, which one? Third ray. Third ray suffers minimum deviation, how much? That is of 120 degree. So that is answer for the third question. So overall 3 questions related to this passage. Question number 1, what is the value of mu? Question number 2, what is the deviation suffered by the ray 2? And third one, what is the minimum deviation suffered by ray 3? Minimum deviation was not asked, but we have to decide that minimum deviation. Why? Because only one condition is given, angle of emergence and angle of incidence both are equal. Based on this condition, we should decide ourselves it is minimum deviation. So the condition minimum deviation was not mentioned in the problem. We should pick up that based on the given data. Okay, let us move on another one. Let us go for a second passage. Passage 2. Already we discussed passage 1 and now it is passage 2. It is a prism. Of course, it is a prism. It is composed by 3 prisms, 2 identical and one more third one is joined together with the 2 identical prisms. As a whole, it is a combination of 3 prisms. We can see here, suppose this is a, say, N, A, B, N, one prism, and B, C, N, another prism, and next one A, C, D is third prism. Okay. Now here 2 identical prisms. One is ACD, 30, 60, 90, and ABN 30, 60, 90. These 2 are identical. 1 and 2, these 2 prisms are identical. And third one is, it is isosceles right angled prism. See, 45, 45, 90. So these 3 prisms are combined together as a whole. So it is a it is a material or transparent material medium. So all these 3 prisms will have the same refractive index. That refractive index is given mu is equal to 2 sin theta 1. 2 sin theta 1. See here, as a whole, this combined prism, that A, B, C, D is the combined prism, on which PQ is the incident ray, which is incidenting on the surface AB at an angle theta 1, undergoes refraction, and finally the ray is given in this problem. Actually this was not mentioned in the problem, and R2 was not mentioned, and this is not mentioned, and this is not mentioned. So everything is given like this, ray path. So by observing this ray path, we can decide what are the angles. The theta 1 and theta 2, these 2 are mentioned and given in the problem. But here, this is the problem given in, shown in the total paragraph or passage. But here, we develop some more supporting points by observing this diagram. So here, this is theta 1, it is bending towards the normal is down here. This is, say, R1, angle of refraction at first face AB, and again it is undergoes TIR, total internal reflection, but here it is a 90 degree, it is traveling inside the prism, it is 90 degree, 45, 90, definitely it is 45, we should develop this, and it is 45, and definitely glancing angle, this is also 45, here normal is drawn, here it is 45, angle of incidence once again it is 45. And again it is 45 angle of reflection, and it is incident over here. So once you observe this, this is also 90 degree for this line. So this is 30 degree, this is 90 degree. So what is this angle? 60 degree. If it is 60 degree, this is total 90. What is this angle? This is a 30 degree. So say it is R2. These 2 values are developed by observing the diagram. Okay, so this is R1 and this is R2. R2 is 30 degree. So this is R1, and at point R the angle of incidence is 45 degree. That was not given in it, but observing the ray diagram, and we developed these values R1 and here 45 degree and here R2 value. These are developed by observing the diagram. Okay, let us move on. First question, that is the angle of refraction on the face AB. So here R1 is how much? Angle of refraction R1 is. So that can be found by using Snell's law. Using Snell's law, its refractive index mu into sine of R1. Mu into sine of R1 is equal to outside refractive index 1 into sine of the angle in the same medium, sine theta 1. Yes, mu is given in the problem. Mu value 2 sine theta 1. Put here 2 sine theta 1. Sine R1 is equal to sine theta 1. Sine theta 1 gets cancelled. Then sine R1 is equal to 2, take this side, 1 by 2. R1 is getting 30 degree. Yes. So first question, answer is over. This is angle of refraction at the face AB. So that is 30 degree. So over. Next go for second problem. That is 20th problem. The ratio theta 1 by theta 2 is equal to how much? Here theta 1 angle of incidence, here angle of emergence theta 2. Their ratio is how much? It's a very simple. Again using Snell's law at AD surface. Here Snell's law using. So here refractive index mu into sine of here R2 is equal to 1 outside 1 into sine of theta 2. Yeah, 1 into sine theta 2 equal to mu sine R2. R2 is already 30 degree, we know, substituted. Sine theta 2 is equal to mu is equal to 2 sine theta 1 into sine 30. Mu value is substituted this much. Already mu is given in the problem. Then sine 30 equal to 1 by 2. Okay. Now 2 gets cancelled. Sine theta 1 equal to sine theta 2. Then what do you say? Theta 1 is equal to theta 2. Therefore theta 1 by theta 2 is equal to 1 over. Second question, and its answer is over. And third question remains, that is question number 21. Total deviation suffered by the light whenever it is exits from the prism. Then find this total deviation. Here one deviation is giving in clockwise. See, here it is extended. Then deviation how much clockwise? How much delta 1 say? Here one more deviation here in the clockwise direction delta 2. See here it is taking small deviation delta 1. Again TIR delta 2 here, and again here delta 3. This is in anti-clockwise delta 3. But here due to refraction delta 1, here due to reflection delta 2, here delta 3 again by refraction. Therefore total deviation equal to delta 1 plus delta 2. These two are in the same sense. Clockwise, this is a clockwise. Here also it is clockwise. These two are clockwise and this is anti-clockwise minus. Delta is equal to, so this is I1 minus R1 plus delta 2 here 180 minus our glancing angle. In terms of glancing is how much? Glancing angle equal to 45 degree. Therefore 2G 45 minus here bending away in anti-clockwise theta 2 minus R2, theta 2 minus R2. Of course here I1 is nothing but I1 is theta 1. Therefore total deviation is equal to theta 1 minus this is 30 plus 2 into 45 glancing angle minus theta 2 plus minus or minus plus R2 is 30. Now this one gets cancelled. Delta is equal to theta 1 minus theta 2 plus 90 degree. But as we know, theta 1 is equal to theta 2 already proved in the second question. So once theta 1 is equal to theta 2 minus theta 2 how much? 0. Therefore deviation equal to 0 plus 90. Finally, total deviation suffered by the light whenever it is exit from the prism after making 2 refractions and 1 total internal reflection. Here refraction 1, here refraction 2, and here TIR. As a whole, total deviation suffered is how much? 90 degree. This is the final answer. Once you check up this, whenever this exit or emerging light is extended back, it is quite parallel to this incident ray. We can understand this ray and this emerging ray both are perpendicular, that is we are obtained 90 degree. Okay. Yeah, next go for passage 3, and again it includes 3 questions. So in this passage, a graph is drawn between angle of deviation and angle of incidence for a prism. Then in this graph, the values are given, the deviation angle and minimum deviation angle, and the angle of incidence was not given, unknown value. This is angle of emergence, this is I1 is equal to I2 conditions. We know regarding the graph related to prism. Okay. So if deviation and angle of incidence graph is drawn for a prism, from this graph the question is find the angle of prism. Find the angle of prism means what is the value of a angle of prism. Question number 2, find the refractive index of material of the prism, mu value. And third question is find angle of incidence I1. Means we can imagine a prism. Okay. So in this prism, this is the angle of incidence. Now a ray incidenting on it. This is I1, and after refraction it is giving emerging ray, and this is the angle of emergence. Okay, and refractive index mu. So for this prism, angle of deviation and angle of incidence graph is clearly mentioned or given in the diagram. Okay. Now let us go for first question, find the angle of prism. Right from this diagram, so whenever the prism is at minimum deviation position, whenever it is at minimum deviation position, where I1 is equal to I2, actually this is I2, 70 is I2, this is I1. So as deviation decreases, then these two will approach, means here I1 increases, I2 will decrease, these two are matching or meeting each other, becomes equal at minimum deviation. Therefore, at minimum deviation position I1 is equal to I2, because I2 approaching, I1 and I2 both are approaching and becomes equal here, that is 60 degree, and delta minimum is equal to formula. Actually delta is equal to, we know, delta equal to I1 plus I2 minus A, this is formula, but I1 is equal to I2 in minimum deviation position. Therefore delta minimum equal to 2I minus A. Therefore delta minimum is, that equal to delta minimum is equal to, that is 60 degree given already, minimum. This is delta minimum, this is delta. Okay, this is delta minimum 60 degree, right? 60 equal to 2 into angle of incidence, so that is 60 degree here given. So substituted by simplifying this 120 minus 60, taking this side, A is equal to 60 degree. This is the angle of prism. That's the first question. And go for the second one, find the refractive index of material of the prism. Okay. So here at minimum deviation position, we can use the formula directly, because mu value refractive index, the refractive index is asked, but remaining sin A plus delta minimum. A is calculated from question number 1, and this is used in the question number 2 directly by using the minimum deviation position. Mu is equal to sin A plus delta minimum by 2 by sin A by 2. Yes, A is there, delta minimum is there. Substitute here. Sin 60 plus 60 by 2 by sin 60 by 2. This is giving sin 60 by sin 30. By simplifying you will get root 3 is the refractive index. Why? Because sin 60 root 3 by 2. This is by 1 by 2. So it gives root 3. Now question number 24, that is third question. Find the angle of incidence and the first refracting surface I1. See here in this diagram. So I1 we have to find here. I2 is already given 70 degree in the diagram. Mu already calculated here. So no need of it mu in finding that. So deviation delta for these values, delta is given clearly. The delta is 65 degree. Therefore, all are there, delta equal to I1 plus I2 minus A. Delta is 65 is equal to I1. We don't know. We have to find this I1. And I2 is given, that is 70 minus A is angle of prism. Angle of prism already calculated in the first question. Therefore, 60 substituted by simplifying, you will get I1 is equal to 55 degree. So this is the passage 3. All 3 questions are over, and next we go for next question. Okay, right.